what is an OSI model, because I think some students are very new to this technology. That's why you need to know about the OSI model. Okay. After OSI model, we will discuss about the inter-networking device. Okay. What are the inter-networking devices like router, switches, hub, and so on? These types of devices we will discuss. In third day, we will discuss about the IP addressing. You know what are the IP addresses? IP addresses are the logical address. Okay. And there are two types of IP address. What are the types of IP address that we are using?
Static and
IPv4 and
S-
IPv6. And in that IPv4 and IPv6, we use static and dynamic IP addresses. Okay. After that, we will discuss about the subnetting, fixed length subnet mask. Then we will discuss about the variable length subnet mask. Okay. This is the most important topic for the interview FLSM and VLSM. Okay. After that, we will discuss about the basic commands on router and switches. Okay. Switches. After this, we will discuss about the broadcast and collision. Okay. Broadcast and collision we will discuss. Okay. This is the basics of the CCNA. These topics are only the basics of the CCNA. Then we will start our topic switching. Okay. Switching. In switching, first topic will be virtual local area network. Second is DTP. What is DTP? Anyone? Then we will discuss about the VTP. Then we will discuss about the STP. And after that, the topic will be IVR, inter-VLAN routing. Okay, IVR. And sixth one is Ether channel. Okay, so these topic will be discussed in which? In what? In the switching. If I talk about the STP, there are some more topics in this. These are the RSTP and MST. So we will discuss about these topics also as in STP. Okay. A part of this, we will, after completion of all the switching topics, we will discuss about what? The routing technology. First of all, we will cover up the static routing, static, static routing. Second is default routing, default routing. Third is dynamic routing. Okay. Now I have some concern with you. Dear, some protocols are not in syllabus, like RIP protocol and EIGRP. These topics are not in our CCNA syllabus. If you want, then I can discuss these topics also. So that's
Sure.
your wish. You want, then I can discuss, but these are not included in your syllabus. If you want to discuss, I will take 2 days 2 days to cover up these also.
Okay.
Okay, you want?
Yes, please.
Okay, I will add these two in the syllabus also. Okay. Then the most important, that is OSPF. Okay. OSPF is really important topic in your routing technology. Okay. Apart of this, we have some different topic than routing is switching. This is DHCP. You know about DHCP? Dynamic Host Control
Yeah.
Protocol. Yeah,
Yes.
that is
Yeah.
also really important. So we will discuss about the DHCP, network address translation. This is the only process that is responsible for the internet in multiple devices using single IP address, NAT and PAT, port address translation and network address translation. Okay,
Mhm.
and we will discuss about the ACL also, that is access control list. This is the part of network security. Okay, access control list we will cover up. This is only the basic of the for the same. Okay, and after that we will discuss about the about what, the IP version 6. Okay,
Mhm.
and after IP version 6 we will discuss about the QoS, quality of service. Okay, and if you want then I will also discuss about the automation. Okay, this will be your syllabus. So any question about the syllabus or the topics that we are going to cover?
Yes.
Yes.
Are we gonna discuss about BGP as well?
Dear, BGP is not in your in the CCNA syllabus actually.
Okay.
Yeah, that is not the part of CCNA syllabus. But if anyone want, then I can give one day for the BGP also. That is your wish.
Sure.
Okay, so that
Mhm.
is additional. Okay, like RIP and EIGRP, I will also add here BGP. Only the basic part of the BGP. Okay,
Sounds good.
basics basics of BGP I will add. Okay, so this will be your syllabus. Any other question?
No, all good.
Okay, that is fine. So this is your syllabus. Okay, so our first topic is what, the OSI model. So today we will discuss about the OSI model. Okay,
Mm-hmm.
so what is OSI model? Anyone can answer me what is OSI model?
I know it's 7 layers.
Okay, these are the 7 layers. Any other answer? And why we call this OSI model reference model? Why this is a reference model?
It's the way the network can communicate with each other, like the
Can I?
communications over a network.
Yeah, your answer is correct. And can I practically, practically can see, can process the OSI model? Can we practically apply the OSI model?
Sure.
Can you show me the where is the OSI model in practical days? Practical? Can you practically show the OSI model anywhere? Anywhere you seen that this computer is working on OSI model, or my network is working on OSI model? Have you ever seen the OSI model anywhere written that there is OSI model working here? Practically, have you seen?
No.
No, because that is only a reference model. If you'll go through, if you will check your internet connectivity, let me show you. When I will open my PC and check my internet connection or local area network connection, the properties here. Okay, what I will find? Let me check my IP addresses. Yeah, this is what. Here you will see that I'm using what? TCP IP model. What I'm using? In practical, we will use only TCP IP model, not the OSI model. Okay, that is why you cannot see the OSI model here. But to understand the networking more deeply, you need to know about the OSI model also. Okay, so that's why we are discussing about the OSI here. Okay, so why we need the OSI model? First of all, if I if I check the history of the networking, the OSI model was introduced in OSI model was, I will give the notes. Okay, these will help you in certification also. These notes. Okay, was introduced in which year? 1979. Okay, and that was not practically implemented. Okay, that was not practically implemented, and this is a reference model. Okay, perfect. And this was accepted by ISO organization. Okay, which organization accepted this? This was ISO, International Standardization Organization. Okay, that is another one. And why we need the OSI model first of all? Why we introduce this one? What were the issues before the OSI model? Let me discuss about this. Okay, like I have a PC here. I have a computer here. Okay, and my friend also has a computer. Okay, my computer is of is which IBM. Let's assume I have purchased an IBM computer and my friend purchased Apple computer. Okay, if I want to communicate IBM with the Apple before before 1979, with before the introduction of OSI model, if I want to communicate IBM with the Apple, these pieces cannot be communicate. Why these pieces cannot communicate? Because there is no reference. There was no reference, rules, and regulation for interconnection. There were nothing like the rules and regulation for the interconnection. That's why the other vendors, the different vendors cannot be able to communicate. Only same vendors can able to communicate before the OSI model. Okay. If I have a PC of IBM and my friend also had a PC of IBM, these can able to communicate. Why? Because same vendors can communicate before the OSI model. After the introduction of OSI model, we have set up the 7 layer of interconnection. What? 7 process of interconnection to communicate in different vendors. By the help of that, the different vendors can able to communicate. Okay? By the help of what? OSI model. By the help of OSI model, we made some rules and regulation. After that, the different vendors can able to communicate. And before that, only the same vendor can able to communicate. Okay. Now clear why we introduced the OSI model? Any question about this?
No, all
Hello.
good.
Okay. So to make the connectivity between the different vendors, we introduce the OSI model. Okay. Perfect. Now now what are the rules and regulation about the OSI model? Okay, first of all, what different vendors can able to communicate after OSI model introduction. Introduction. Okay, after the introduction of OSI model, the different vendors can able to communicate. Second one is what different vendors can send or receive data. Okay, perfect. So there were 7 layers of interconnection. What? 7 layers of interconnection. What are the 7 layers? What are the 7 layers in OSI model?
Uh,
Physical,
Physical layer. Okay.
data link,
Physical layer. Second is data link. Okay. Third one is what?
and we should say it in order, yeah.
That is network layer. Okay. So if I
Net
talk, yeah. Third one is
network
network
transport
layer,
session
transport, session layer, presentation layer, and application
application.
layer. Yeah. Okay, let me note down in reverse order. Okay, application, then which one? Presentation, presentation. Third one is what? Session layer. Fourth one is what? transport layer. Fifth one is what?
Network.
Network layer, which is sixth one. That is
Data link.
data link layer. Okay. And last one is what?
Physical.
Physical layer. Now I have a very important question. Okay. Which is the first layer among these 7 layers?
Data
What is your
physical.
question?
My question is that which is the first layer of interconnection in these
Physical.
7 layers? Okay, one answer is physical layer. Any other? Which is the
Data.
data link layer is the first layer.
The second one.
No. So one person answered that the physical layer is the first layer. Okay. And what about the application layer? This layer is not the first layer.
Like, can you ask your question again, please?
Yeah.
What is your question?
Yeah. Which layer is the first layer of interconnection in these 7 layers? Application, presentation, session, transport, network, data, or physical? Which layer is the first layer?
On TCP IP.
Yeah. In the OSI model, in reference model, when we do communication between two different devices, which layer works? Which layer is the first layer?
Network.
Network layer. Okay. So dear first layer, if I talk about the first layer, okay, let me answer
Internet.
the internet. Okay. Dear, the first layer depends on the which side you are communicating, or where on which side you are doing the communication. Okay, let me discuss about this. Okay, just give me okay. So these 7 layers are, let me note down these 7 layers. First is application layer. Okay, second one is what? Presentation layer. Okay, presentation layer. Third one is what? Session layer. Okay, fourth one is what? Transport layer. Okay, fifth one is what? Network layer.
That's an OSI model, yeah.
Yeah, this is the OSI model, the 7 layers of OSI model. Data link layer. Okay, and seventh is what? The
Physical.
physical layer. So I'm asking that which layer which layer is the first layer in the interconnection? Which layer will be the first layer to in the communication?
Application.
Application layer. Okay, one answer is application layer. Any other answer?
Transport.
Transport. Okay, one. Okay. Any other answer?
Network interface.
Okay. Let me answer your question. Okay. So the first layer depends on which side you are. Okay, which side you are working. Okay. Let me copy this and paste it here. Okay. How do the communication work? If I am sender here, what? If I am sender, okay, and this is a receiver here. Okay. Dear, the first layer depends on which side you are. The communication starts from application layer and go to the physical layer. After physical layer, the data move to the physical layer of the sender, and the data again move to application layer of the receiver. This is way of communication. Okay, first of all, the data will be generated on the application layer. Okay, this layer will generate the data. This is the human interaction layer. Application layer is the human interaction layer. Then the data will be forwarded to presentation layer, on which the encryption and decryption will be started. Then after this, the data will be forwarded to the session layer. This will initiate the session, and when the data transfer will be done, the session layer of the receiver will end the session. parallelly these process will be done. Here we will initiate the session. Here we will terminate the session. Okay. Here in the transport layer, the data will be forwarded to transport layer. Then the data will be forwarded to network layer, in which the data will be transformed into the packet. Then packet will be transformed into the frames. Frames will transform the data into what? Bits. Because if you will check the data communication in the is done in the form of bits. In which form the data is transferred? In form of bits. What are the bits? Bits are the combination of 0 1 0 1 0 1, like this. The data will be transferred in form of this. Okay. So the reverse process will be done here. Okay. So this will initiate the process and receiver will end the process. Okay. This is how the OSI model will work. This is my data. Data will be generated from application layer, that will be moved to physical layer. After physical layer, from the receiver side, first layer will be what? Physical layer. Okay. So first layer for the sender is application layer, and first layer for the receiver is what? Physical layer. Okay. Okay, everyone.
Yes.
Okay. Now any question about which is the first layer? So application layer is the first layer for the sender, and for the receiver, the first layer is what? A physical layer, because physical layer will trans will forward the data to the data link layer, then the data link layer to network, then transport, then session, then presentation, then application layer. Okay. This is the step by step. Okay. Now another question is what is the format of data in these layers? Hello.
Are you referring to TCP and UDP?
No, no, no. What is the data form? Like packet or
Oh,
frame or bit? What is the form of data in every single layer? Okay, let me answer you. In application layer, the data will be in form of PDU. Okay,
okay.
you can note down the data on the application layer in form of PDU. Okay, and if I talk about the top three layer, on presentation layer, the data is also in form of PDU. On session layer, the data is also in form of PDU. If I talk about the transport layer, the data will be will be transformed into segmentation. Okay, here the segmentation of data will be done. After the segmentation, the data will be transformed into the packets. Okay. If you will ask what is the packet is what? Packet is what? Packet is equal to segmentation plus IP address. Okay. Segmentation plus IP address is called what? Packet. Okay. And if I talk about the data link layer, on data link layer, this is also called the MAC address layer. On this layer, the data will be in the form of frames. Okay. You know what is the meaning of frames? That will be equal to packet plus MAC address plus what? Parity. We will discuss about the parity in upcoming upcoming topics. Okay. In physical layer, the data will be in form of bits. So these are the different forms of data on different layers. Okay, you can note down this also. Okay, everyone.
Yes.
Okay. So any question about this?
I'm good from my side.
Okay.
I'm good.
Okay. Okay. Everyone got this? Okay. So now Next topic, that is what? Application layer. What is the work of our application layer? Application layer. So can anyone tell me what is the work of application layer?
Could it be anywhere between like a website or another workplace or end destination basically?
Very well, very well. This is the starting and the ending destination of any data, right?
Yeah.
Yeah. So if I talk about the very simple language, you can say this layer is called human machine interaction layer. Okay. Why? Because this is the layer where the data is generated. Okay.
Okay.
This layer provides an interface interface to the user for using an application to generate data. Okay, like I'm using the Google Chrome. Okay, Google Chrome is an application. Okay, I can generate data by the help of Google Chrome or not. Yes, I can generate the data. Okay, I'm using a website like Google Sheet. I'm putting some data information there. What I'm doing, I'm generating the data. So that data is generated by the application layer. Okay. On that application layer, some of the most important uh, protocols are working. What are the protocols that are working on the application layer? These protocols are what? HTTP protocol. Okay. HTTPS protocol and FTP protocol. Okay. And TFTP protocol. So these protocols are working on what? Application layer. Okay. So you know about all these protocols or not? May I have to discuss about these protocols also?
I'm familiar with HTTP, HTTPS, FTP,
Okay.
TFTP. Need to understand.
Okay. Any other? So may I have to discuss with these protocols also?
The same. I
Okay.
know
So
what
you
is HTTP,
so
HTTPS also.
okay. So everyone know about all these. I mean what? Protocols. Okay, so we will skip this topic. Okay, so next layer is
Does
what?
FTP,
FTP is the file transfer.
TFTP?
Yeah, file transfer protocol. Okay,
Okay.
because in TFTP you will find that the data will be forwarded in UDP protocol, and this protocol is what? An unreliable protocol. Okay,
Okay.
in TFTP the important thing is that this protocol work on UDP protocol, and also this is unreliable. Unreliable what? Because if the data will be lost, we cannot we will not have any information about the data loss. There is no three-way handshake process in this. Okay. This TFTP is used in local area network only. Okay. In small network we can use the UDP because in the small network we don't need any any three-way handshake process or something like this. Okay, in small network we can use the UDP protocol. So if you will talk about the data loss can be possible in large networks only. Okay, so in small network like 3 to 4 system or 5 PC, we can use this TFTP protocol to transfer the data. Okay. and UDP is somehow faster than what TCP. Okay, that is why this is unreliable, because data loss can be possible here. Okay, everyone.
Okay.
Yeah. And what is the next layer? That is presentation layer. Okay, presentation layer. What is the work of this layer now? Hello.
What was your question? I'm sorry.
Yeah, this is my question. What is the work of this layer?
With presenting, I think it doesn't put the packet together.
Okay, someone is telling me that this will make the packet together. Any other? So if I talk about the presentation layer, the three main tasks will be done here. First is what? The first work is data compression. Okay, the data compression will be done on this layer, and if one side this layer is compressing the data, then on the receiver end this will decompress the data. Okay, because both will happen on simultaneously. If I'm sending the data compression is doing on one side, then on the receiver end the presentation layer will decompress the data. So I can note down the data compression or decompression, right?
Yeah.
Yeah. And other one is what?
Encryption.
Yeah, encryption. Very well. Encryption. And third one is what?
And
Translation of data. Okay, the translation of data will also be happening here. How the translation of data will be done? Because if I'm writing a application, writing a letter in what? In MS Word. Okay, I'm writing a letter in MS Word. Okay, that is my English language, right? English language. This data will what? And how the computer will read this data? In form of doc file. Perfect. I'm writing my letter in English. I'm writing an email or something in my MS Word. So data will be in English, but my computer will understand that this is a doc file, and that data will be converted to what? Some in some computer language. Okay, computer language. So this is what this is called the translation of data. Okay, and about the encryption and decryption. Okay, let's discuss about that one also. Encryption and decryption about the data. Okay, chart 256 to plain text. Okay, what I'm doing, I'm writing some data here. What? Hello everyone, how are you? I'm writing a line like this. Okay. So if I will press encryption, you will see that the data is in different form. Okay.
yeah.
Okay. And also let me take a complete. what- Let me copy this one text here. Okay, and paste multiple time. Okay. I have a big paragraph here. When I will press encryption, you can see the data is only in one line. Okay, perfect.
Uh, so what are you doing now? What are you like trying to
Here
do?
I'm encrypting the data. My data. This is the paragraph of my data. Perfect.
Okay.
This paragraph is converted in a single line of data.
Okay.
Okay, this is called encryption. Can you read this?
Yeah.
No, but you can understand this one also. Hello everyone. Okay, let me note down a complete paragraph. Hello everyone. Everyone, how are you? Okay, let's take some text here. Okay, OSI model. Okay, this is the definition of OSI model. Let me copy this one. Okay, let me encrypt this one. This is what? This is approx 8 lines, right? When I will encrypt, this will be one line of data. See, the data will be in single line. So this is called what? Encryption and compression. Okay,
Yeah, but it's encrypt about the
this
first
yeah.
like hello everyone, how are you?
No, this is the encryption of complete data, complete paragraph. When I will encrypt this paragraph, this will be in form of like this. This is called
Okay.
encryption. Okay,
Okay.
this encryption and compression is also done on the on what in your presentation layer. Okay, everyone.
Okay.
Yeah, you can also do the practical. There are several encryption language like MD5, SHA-224, SHA-256 here. So if I will open my website core core networking classes.com. So I'm opening my website. Here you can see this is what? This is what? This is a secure connection. Why? Why? Because I'm using what? HTTPS. Because of HTTPS, you can see a log signal here. That is what? This is an encryption. If I will open this, this will show that your information, password, everything is encrypted. Okay? Why? Because because the encryption is done by the help of some protocols here. Okay?
Yep.
So the if I talk about the HTTP, this is hypertext transfer protocol. This protocol is not secure because this protocol send the data in form of what? Plain text. Okay, and HTTPS will forward the data in form of what? Encrypted data. Okay, with some certificates. Okay, everyone.
Okay.
Okay, perfect. So we discussed about the presentation layer here. Okay, after presentation layer, you know that the encryption decryption will be done on this layer. Translation of the data will also be done on the same layer. After the encryption decryption, the the data will be forwarded to the session layer. So what is the work of the session layer? Can anyone answer me? What is the work of session layer? Hello.
I don't know.
Okay. Any other? Okay. So the session layer is responsible for initiate, initiate, monitor or termination of session. Okay. And what is the meaning of session? What is the meaning of session? Session, the meaning of session is time to do some activity. Okay. Activity.
Okay.
Okay. So time to do some activity is called the session. So this layer will initiate the session that let's start transferring the data. Okay, this layer will open all the sessions and the data will start transfer. Okay, this layer will start the session and the session also monitor the session. Okay, so the meaning of session is what? Time to do some activity. So session layer will initiate the session, monitor the session, and also the termination of the session. This will also end the session. And if I talk about what? If I talk about the other process in session layer. So there are three processes. We call it 3A processes. Okay. 3A process also will be done here. What are the 3A processes? Authentication. Authentication. Okay. Second one is what? The authentication will be done here. Authorization. Authorization. And third one is what? Accounting. So these process will also be done on which layer? Session layer. So now you will answer me what is authentication.
It's like verification.
Verification, very well. So this layer will not open the session for everyone. This will only open the session for limited tasks. Perfect. And for that, this layer will need some authentication. The authentication will check that the valid user or not, and how the session will know that the user is valid or not, by the help of passwords or passwords or pin. All these passwords and pin will be entered in authentication process. Okay, perfect. To check the validity of the user. Okay, this process is done by the session layer. Okay, what is the authorization?
Isn't it like allowing and denying
Yeah,
access?
allowing and denying, allowing and denying, but 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 on basis of availability. Okay, if you want to send 100 GB of data, okay, how much? 100 GB of data, but your network can only send 10 GB. So that data cannot be sent, that data cannot able to send by your network, because the data is not capable of send this much data. This authorization will also be done by the by what by what the session layer. That are you capable of sending data or not? So to check the capability, authorization means the capability. Okay, this will deny that you cannot send the data. Okay, there are so many factors, not only the data, but there are so many factors on which the authorization will work. This is a simple example about that. Okay, so allowing or deny the data on the basis of availability. So that was an example. Let me delete this one. So on the basis of availability. Okay. And third one is accounting. Okay. What
Is,
is the main?
is it
Yes.
the time on session?
Yeah. Perfect. Okay. So what is the meaning of accounting? That this will make a database lookup. Why this will make the database lookup? To 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 what? To uh, this will make a database table to note down for how much time the data, the session was open. Okay, open. Okay, so this will note down all the processes done in what? In our session. That for how much time the session was initiated, for how much time we have opened up the session, and at which time we terminated the session, for how long the session was working. Okay, so all this is called accounting of the data. Okay, this will make a database table to look up that for how long the session was opened up. Okay. Okay, everyone.
Yes.
Okay. Let me give some let me give you a short example to remember all these three A's. Okay. If you will go to your nearest ATM, okay, you will find that first of all, ATM will ask you a pin. Okay, perfect. That is means the ATM is doing what? Authentication. Perfect. Authenticate. That is a simple example of what? Of session. First of all, your ATM will ask about the authentication. That means a PIN code. Then that will check the authorization. Authorization. That that do you have sufficient amount to withdraw or not? Sufficient amount to to withdrawal. Okay, that will check that are you do you have a balance of $1,000 or $2,000 to withdraw or not. That is called authorization. Third is what accounting. This will also maintain a database lookup that how much money you have withdrawn. Okay, so these are the simple example of the 3 years. Okay, if you will forgot, just remember the ATM example. Okay, everyone.
Yes.
Okay, perfect. So next layer is what?
Transport.
Transport layer. So if I talk about the above three layer, a session layer or application layer and presentation layer, the data was in the form of what? PDU. Okay.
Mhm.
So data was in the form of PDU in all these three layers. Okay. Now, if I talk about the transport layer, so what is the work of transport layer? So this layer is responsible to to transmit. You can say transmission of data. Okay. This layer is responsible for the transmission of the data. And on this layer, there are two protocols which work on this layer. What are the protocols? UDP, and second one is what? TCP protocol.
TCP.
Yeah, TCP and UDP protocol will work here. Okay. So what are the TCP and UDP protocol? Let's discuss about this one. So what is the TCP protocol? TCP is the transmission control protocol. Perfect. Okay. And UDP is what? I will note down UDP here. UDP is what? User Datagram Protocol. Perfect. Okay, everyone? Or not?
Yes.
Okay. So what are the work of these two layers? These two protocols.
What was the question again? I'm sorry.
What are the work of these two protocols?
Was it transporting the packets or the session between layers?
Yeah, transmission of the data between the two different networks. Okay, perfect. The answer is correct. But here there are some some more to discuss in this. First of all, the TCP is a slow protocol. This is a slow protocol. On the other end, this is a faster protocol. Okay. This is somehow faster protocol. If I talk about this one, this will follow three-way handshake process. Okay, not follow three-way handshake. Okay, this is a reliable protocol. Reliable protocol. Okay, this is unreliable. This protocol is unreliable protocol. Okay, why this TCP protocol is slower and why the UDP is faster? Okay, so why the UDP is faster as comparison to TCP protocol? Just answer me quickly.
Why? What
Why
was the question? I'm sorry.
why TCP is fast? Why TCP is slower and UDP is faster?
Speak.
TCP is following three-way handshake and the UDP is not following three-way handshake.
Yeah, that was the perfect answer because TCP is a slow protocol because it's using the three-way handshake process. But the UDP doesn't follow the three-way handshake process. This is unreliable. Now I will tell you what is the three-way handshake process. This is my sender and this is my receiver. The sender name is Sam. Sam is sending some data here and Bob is receiving the data here. Okay, I'm sending the data from Sam to Bob like this. Okay, okay. I'm sending the data like this. Okay, I've sent 1 GB of data here. How much? 1 GB of data I have sent from Sam to Bob, and I'm not asking that Bob, have you received the data or not? In what? In UDP, I'm sending the data, 1 GB of data, and without asking that, Bob, have you received the data or not? You getting my point? I'm sending the data from Sam without asking Bob that, Bob, have you received the data or not? I'm not asking the Bob, have you received the data? So this is what a UDP protocol. Why? What will happen that we will not ask any acknowledgement from the Bob. I'm sending the data and after sending the data, I'm not asking any acknowledgement from the Bob. This will be happen in what? In where? UDP protocol. I'm continue sending the data without asking any acknowledgement that have you received data or not. Okay. If you have seen any live streaming, have you seen cricket or football match? Hello?
Yeah. What was the question again? I'm sorry.
Have you seen live streaming like cricket match or football match on
Yes.
live telecast? Here
Yes.
is that broadcast is having any acknowledgement. I mean, if you miss a goal or then can you again watch it at the same time? If you're doing
No.
some video call and you missed a 30-second of with
No.
your friend, can you again able to see that one?
No.
Uh,
No, because
I have
the
question.
what?
I have question. I didn't get it. Can you just explain it, please,
Yeah, I
one
will
more time?
explain. Yeah, I will explain more clear. Okay. So first of all, discuss the three-way handshake process. Okay. What is a three-way handshake process? First of all, discuss with the three about the three-way handshake process. Okay. So what is a three-way handshake process? Okay. So what will happen in the three-way handshake process? This is my sender. Okay. And this is a receiver here. Okay. I'm discussing about the TCP protocol. TCP protocol. Okay. What will happen in three TCP protocol? I have one side there is Sam, other side is a person Bob. These are friends the Sam is sending a data of what? 1 GB of data to the Bob. Okay, how much data? 1 GB. 1 GB of data. First, Sam will send how much? 10 MB. Okay, first Sam in first the Sam will send 10 MB of data and will ask Bob, have you got the data? So Sam will send an acknowledgement. Yes, I got the data. You can send next 10 MB from your database. Then it will send the acknowledgement and sync signal that yes, I've sent the data. Okay. So this process in done will be done in three way. How much? In three steps. First, it will send the data. Then it will the Bob will send an acknowledgement. First of all, data will be sent. Then the Bob will send what? Sync plus acknowledgement here. Okay. Again, the Sam will send what? Acknowledgement from Sam. So in this you can see first we have sent the data, then Bob sent sync plus acknowledgement, then we again send the acknowledgement signal. That means zero data loss because after sending every packet of data we ask that Bob, have you received that data or not? If the Bob hasn't received that data, then we again send the same data. Okay, that is happening in what? TCP protocol. That is why this protocol is reliable protocol, because every time I'm asking Bob, have you received data or not, by the help of acknowledgement message, and when I will get the acknowledgement message I will again send the acknowledgement. Okay, I'm sending the next packet. So that is happening in what? TCP protocol. Now you got what is the point behind the TCP? Why this is slower? Because this is always doing the three-way process. If you are downloading some data from internet, there's have you seen any data loss in your downloading? Like you're downloading a software or antivirus from any website, does there any data loss in the antivirus or any setup of that software? Have you seen any data loss there?
No.
No, because that work on the basis of TCP protocol. Okay. If I talk about the live streaming, there is so much data loss that is happened because of UDP protocol. You got this point?
Yeah.
What is three-way handshake?
Oh, so that's a three handshake, yeah?
Yeah, that is a three-way handshake.
So the first one sends the data.
Yeah,
Then
first
second,
we will send the data in parts, and then we will ask that have you got the data? Then again I will send the same data. Then I will again ask that have you got the data? Every time I will send the data and ask that have you sent the data or not? Then I will send the next packet of the data.
so they send it on two packets.
Yeah, this is my complete data of 1 GB. Perfect. I will do what? I will do the slicing of data like this. 10 MB, 10 MB, 10 MB like this. And I will do the slicing of data like this. Complete slicing of data. Then we will start sending the first packet. This will be our first packet. I will send the first packet here. Like this is one. I will send the first packet here and will ask that have you got the data first packet? The Bob will reply, yes, I got the first packet. You can send the next packet. Then it will receive the first packet here. Okay. Now it will send the second packet here after completely receive the first packet. So in this you can see that we are sending the data in parts, right?
Yeah.
That is why there is no loss of data. And if I talk about the UDP protocol, here is Sam, here is Bob, and this is what 1 GB of data, 1 GB of data, and with 1 GB of data, I will send complete 1 GB of data from Sam to Bob without any acknowledgement. If there will be any loss in the data, Sam will never get any acknowledgement that the data is sent or not. Okay, that is happen in what? In UDP protocol. Okay, we will send a complete data in one shot, one time. We will not ask that have you received data or not, like this. This has happened in what? UDP protocol. This is an example of UDP protocol. There is no acknowledgement. That is why this is unreliable protocol. Now you have any question about UDP protocol?
So that's different between both, yeah.
Yeah, that is the difference, that in TCP protocol we will send smaller amount of data every time, and will check that the data is sent or not. But in case of UDP protocol, we will not ask any acknowledgement. We will send the data without any acknowledgement.
And
The other one is received or not. We are not responsible for the loss of data.
and on UDP, there's no lost data.
Dear, that is loss of data. There can be loss of data because there is no acknowledgement. No acknowledgement here. So that is why the data loss can be possible here, because this is 1 GB of data. I'm sending the 1 GB of data. This is 1 GB of data. Okay. And what will happen, that due to some network issue, we lost this data from here. So no, not the Bob or not the same the say Sam will know that the data loss happened here or not, because there is no acknowledgement of loss of data. You got the point?
Yeah.
Yeah. This is happening here. This is loss of data here. No one will know that this loss will happen anywhere in the network, because we are using the UDP protocol. So now you got why the UDP is faster. Because it's not using the three-way handshake process, and this process, data sync acknowledgement and acknowledgement, is called a three-way handshake process. That's why TCP protocol is slower as compared to UDP protocol, because this is asking the acknowledgement every time. Okay.
And the TCP protocol, it's faster than the TCP protocol.
Yeah, this is reliable but slower. TCP is reliable but slower protocol, because after sending every packet you will get an acknowledgement, and that will consume your timing. Okay.
Yeah.
Okay.
Okay.
Okay. Or I have to explain again? Don't worry, I can explain again.
I have another question. Sorry.
Yes, you
And
can ask. Yes, you can ask.
when like we should know where or how to use the TCP protocol or the UDP.
Okay, okay. How to use that? There that depend on the which protocol you are using. Okay. There are different protocol, and there are different what method of sending the data. Okay. If you are doing a video call, that will automatically pick the UDP. Perfect. That will
Okay.
automatically pick the UDP in case of live streaming or any video call or audio call you are doing. In case, that will automatically pick the UDP. That depend on what type of work you are doing, which protocol you are using. Like in case of routing, there are number of protocol, but if I talk about the RIP protocol automatically using the UDP protocol. Okay, you cannot
Okay.
change that one. So that depends on which protocol you are using. That's why RIP protocol is limited in a local area network, in LAN connection. That is why this is happening. Okay.
Okay.
Okay. Any other question? Hello?
Yeah, all good for my side.
Any confusion? Any question from anyone? Khalid, Said, Francisco,
No, I'm good.
Priyanka. Everyone is okay with this?
Yeah, I'm fine.
Okay, Francisco,
Yeah.
are you okay with this? Priyanka?
Yes, Neeraj, I'm okay with this.
Okay, okay, okay.
Yes, I'm fine.
Okay, 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 perfect. So let's come to our next layer. Which is our next layer? And let me give you some real life example of the TCP protocol. So have you sent any WhatsApp message to your friend or something? There is something called blue tick. Have you seen the blue tick? Blue tick in WhatsApp message like this. There's a double blue tick here in WhatsApp
Yes,
message. Yeah, that is that is an example of an acknowledgement. Yes, the receiver is received the data. Received your hello message. You will get a blue tick sign. That means the data is transferred. That the receiver has received the data. That is an example of TCP. Okay, that is a real life example of TCP. Okay.
okay, Neeraj.
Okay. So our next protocol is what? Network layer. Next layer is what? Network layer. Okay. So what is network layer?
See routers,
Yeah. Very well. Router. Okay.
routing.
Routing. Very well. And routing is done on IP addresses. Routing is done on the basis of what? IP addresses. Okay. Network layer is responsible for the logical addressing, and this layer responsible for routing, and this layer is also responsible for the best path selection in different protocol, in different what, different routing protocol. Okay, so these all work will be done on what, in what, on
Network layer.
network layer. So anyone is familiar with any protocol like have anyone have studied about the any of these protocols? REAP, IGRP, or OSPF.
OSPF, EHRP, yeah.
So you already have familiar with all these?
Yeah, sort of.
Okay, okay. Any other?
Uh,
Hello. Have you studied about any of these protocols?
Can you ask again?
So any one of you know about these protocol, REAP, IGRP, or OSPF?
No.
No. Okay, so this question is for the person. Okay, let's assume I have a network like this. I have a router here. Okay, one more router here, one more router here, one more router here, one more router here. Okay, perfect. And another one, two router here, and a single router here. Okay, and these all are connected with everyone. Okay, let me open the network. Then I will ask you some questions. Okay, let me make a virtual link. Okay, like these are connected like this. Okay, okay, these are connected like this. Perfect. And there is a switch here and a PC here. I'm just using this topology to ask a question. Okay, and you will answer me correct if you have studied about any. Okay. Okay. So the links are as that this is 1 GB of the 1 Gbps link. This is also 1 Gbps link. This is also 1 Gbps link. Okay. This is what this is 10 Gbps. Okay. 10 Gbps. Okay. And this is what this is 100 Mbps of link. Okay. So my question is that which is the best path?
The best part is what do you, like, what do you mean? Like the faster?
Which is which is the best path? I'm not asking about the faster.
Which, oh, okay.
Okay, I'm asking for which is the best path.
Wouldn't be,
Which path will be followed by you if you are using the routing? Which path will be selected?
The path which is having the lower value, like which is going through 1 Gbps link.
1 Gbps thing. But if I talk about this one, this is 10 Gbps. This is 1 Gbps. This is 10 Gbps. Okay, and lowest one is what 100 Mbps. So which protocol will be selected? Which will be the best path for you?
The lowest one, the which is
100
having,
Mbps.
yes.
Okay, this will be the slowest path. And this is the fastest path, 100 Mbps, 10 Gbps, and this is mediator, 1 Gbps. So which will be the best path? And which path will be selected by which protocol?
wouldn't
That
be
is
the,
that is a confusing question, right?
I'm just confused.
Okay. So let me answer you the question. Okay. Or I will answer this this question in our routing protocols. Okay.
Yeah, I'm also confused.
You're also confused because there are three protocols: RIP protocol, EIGRP protocol, and OSPF. Okay. When we will discuss these three protocols, I will answer this question. Okay. Or you need the answer now.
Wouldn't you use OSPF in this kind of,
Yeah. So there for the different protocols, the path will be different. Okay. If I talk about the RIP protocol will select this path, 100 Mbps automatically. Okay.
yeah.
Because RIP protocols work on the number of hop count. The least number of router in the path will be selected. Okay. If I talk about the OSPF or EIGRP, OSPF or EIGRP, these protocol will select what? This path, the fastest path. Okay, because these two will use the dual algorithm and what shortest path first algorithm. So we will discuss about these algorithm in our upcoming days. Okay, so according to these protocols, these algorithm, dual algorithm and SPF, there the OSPF and GRP in EIGRP will select this path. This path will not selected by any protocol. Okay.
Yeah.
Okay, everyone.
Okay.
Okay.
So we will discuss all this in our upcoming days. Okay, when we will discuss about the routing protocol. Okay. So this will be the best path selection mechanism. That will be done automatically by the help of what? By the protocols. Let me copy and paste in that. Okay. So we will discuss about it. about all this in our routing protocol. Okay. What was the so you got the point. What is network layer? This is responsible for the IP addressing. And after this OSI model, we will start our IP addressing. Okay.
Okay.
Yes.
Okay. And also, if I talk about the network layer, the data will be in form of what? What? Packets. Okay.
Okay.
If someone asks you what is the data in, what is the format of data in what? In network layer, data is in form of packets. Okay. What is a packet? Packet is equal to, I already told you, packet is equal to what? Segmentation of data plus IP addressing. Okay. IP addressing is logical addressing. This is a temporary. And if I talk about the permanent address, what is permanent address is equal to what? MAC address. Okay. Perfect. Any question with network layer?
No.
Anyone? Okay. So next one is what? Which one? Data link layer. Okay. Data link layer. Okay.
Neeraj, sorry to interrupt you. I just want to ask,
Yes, you can ask me.
is there any headers are added in the IP address packet?
Yes, there will be addition of some headers in the IP addresses. Yeah, there will be surely addition of IP address header there. So we will discuss about the TCP/IP header in our TCP/IP model. Okay, that is
Oh,
a wide topic.
okay.
Okay, so don't worry about that. Okay, so we will discuss about the header also. Okay,
Okay.
and if I talk about talk about the data link layer, what will happen in the data link layer? Now your answer, data link layer. On the data link layer, we do the encapsulation. Encapsulation and what? De-encapsulation. Okay. So encapsulation will be done on the data link layer. On this layer, we will add the header. Okay. With the data. Okay.
Got it.
Yeah.
Yeah. Because if I talk about this one, we will add some information here also, because IP address is also some information, because source IP and destination IP will be added with the segment. So that is all, that is called a packet. Yeah, in packet you will also find that the header information is added up. That is source IP and destination IP. Okay. Next is what? Data link layer, on which encapsulation is done. What is the meaning of encapsulation? Encapsulation means addition of some information, info, like I have done on the packet also. But on packet we added only the IP address. Some info, what kind of information, like MAC addresses we will add here. Okay. So in case of encapsulation, MAC address plus what? Plus I will add what?
So,
What? Sequencing. We will do the sequencing here. Okay. What is the meaning of sequencing? Sequencing. We will discuss about this one also. Okay. So what is the meaning of encapsulation? That we will add some data with my. So let me draw a diagram. What will happen? Okay. This is my data packet. Okay. This is my data segment. I mean, this is my PDU. I will do the segmentation of this data like this. I will do the slicing of data on my transport layer like this. Okay. This is the slicing of data I have done. Okay. On this data, what I have done, like this is the data. Let me copy this one here. So this is my data again. Let me zoom this one. So this is the data. What I have added some information here. Okay, like what? Source IP and destination IP. If I will add the source IP and destination IP, it will what I call this? This is called a packet. Okay, you got the point?
Yes.
Okay, let me copy this one. And when this data will be forwarded to what? What? On on my on my data link layer, what will happen? Let me copy this one, paste here. This is my data. What I will do? I will add some more information here. Okay. What will be the information that I will add here? I will add some more information here. This information will be the source MAC and destination MAC. Okay. And I will also add some what what sequencing information. What sequencing information? Sequencing information. Okay. This is called what? This is called what? Frame. If I talk about the data link layer, on data link layer, the data will be forwarded in form of frames. Okay. Okay, anyone, any question about this?
I'm good
Hello.
from my side. I'm good from my side.
Okay. And
I'm confused a little bit.
yes, you can ask me what is the confusion. Okay. Yes, tell me.
So, can you explain it again, please?
Yeah. Here, what has happened? This is a summary of my OSI model. Okay, about the data. Okay, the data was in form of PDU. Perfect. When on the top three layer, application layer, presentation layer, or session layer. On these layers, the data was in form of PDU. On which on transport layer we start the slicing of the data. Okay, what is the meaning of slicing? The breaking of the data in small segments. Okay.
Okay.
Okay. After that, the transport layer, we will the next layer is what? Network layer. On network layer, we have added the routing information, source IP and destination IP. Okay. This is the addition. Source IP and destination IP. This is my data. Like this was my data here. Data. Okay. I have added the information here. Okay, that was my data here. Data. Okay, when I will zoom this will you will see the data like this. Okay, on network layer we will add the source information and destination IP address. Okay, after that we will add the on my next layer, which is data link layer. What will happen? We will add some more information here. What are the information? That is source MAC and destination MAC. Because on data link layer, we will the communication will be done on the basis of what? MAC addresses. Okay. After this layer, the next layer is what? Physical layer. Physical layer. Okay. In physical layer, the data will be formed in the form of 010101 bit form. Okay. And this form is called what? Bit. Okay. So if I ask you what is the format of data, you can say on application presentation or session layer, the data is in form of what? PDU. And if I talk about the transport layer, the data is in form of segments. And if I talk about the network layer, the data will be in form of packet. and after that the data will be in form of frames, and last the data is in form of bits. Okay, and there is something called, what is called window. Now I have a question, what is window and what is window size now? Have you ever heard about window size?
No.
Okay, dear, this packet, which one? This data, after the slicing of data, this data, the data sent without acknowledgement, the data that is needed to be sliced again, that data is called what? Window. Like my my network can send 10 Mbps data at same time, Mbps of data at same time at one time. This capacity of my network is called what? Window. Okay, and this size is called window size. Okay, everyone.
Yes.
The
Okay.
capacity of sending the data at once without acknowledgement is called Windows size. Like I've sent 10 Mbps and then I got the acknowledgement. This is my capacity of network. The minimum capacity of network to send the data is called my window size. Okay, everyone?
Yes.
Okay.
Any confusion about the window? What is the meaning of windows?
No.
No.
Okay. Okay. So that was the OSI model here. Any question with the OSI model?
No, that'll be it.
I think that is the that is best explanation for the OSI model and easy to understand. So that's all for today. So
I think you
any
missed.
yes.
Did you miss the physical layer? I mean, the last one.
Okay,
What
physical layer. Dear,
consider
yeah, on physical layer, the data will be transformed in on the work of physical layer only to transmit the data in form of bits. Okay, in form of bits.
got it.
Yeah. That is only the work of physical layer. You are doing the connectivity of wires here or Wi-Fi by the help of Wi-Fi 2.4G or 5G or any other device you are transmitting or receiving the data. The transmitter and receiver will work here either in form of cable or wireless. Okay, this will
Got it.
and the data will always send in the form of bits 0101. This is called what? This is called what?
Physical.
Physical layer, the work of physical. Okay, everyone. So, any
Got
question
it.
from the OSI model?
Yep. That'll be it.
Okay, okay.
Neeraj, do we get study material or notes for this?
Yeah, I will send these slides in your Google Drive. You will find these slides on the Google Drive.
Okay.
Okay. Are you okay with these slides?
Yeah. Which emails do we send them? Do you
Just check. All of you just send me your email on the WhatsApp. Okay, I will add you in my I will add you on my Google Drive. Okay.
Sounds good.
Okay.
Yeah, just send me on my Google. Just send your email IDs in your WhatsApp group. Okay, I will add everyone, and I will also upload the video there. Okay. Okay, everyone. Have a good day. Just send in the group on the
I will,
WhatsApp group, please.
okay.
Okay, just
I will.
send in the WhatsApp group. Okay.
Thank you.
Okay. Have a nice day, everyone. Good
Have a
night.
nice day. Thank you.
I hope you like the session.